Welcome everyone. Sorry for the delay. Apparently there was some wireless issue, and so that got us delayed. First of all, I would like to welcome you all to LUMS and the Syed Babali School of Science and Engineering. We're delighted to have you. And in today's session, we plan to introduce you to different academic pathways you can take as students, and maybe most of the experience you will have. So this is a different session because, and I would say a session that we have not conducted in previous orientations. And the way Dr. Ammar and myself structured this is to give you some concrete examples of why SSC is different and what kind of experiences you can get from the SSC curriculum, the research it offers, and the interaction with faculty and staff and so on, right? So with that, let me actually introduce myself and Dr. Ammar. So I am an associate professor of computer science here at SSC, and I have been around for almost 10 years. One of the interesting things about Dr. Ammar and myself, perhaps, is that we were both LUMS undergrad. And so we have seen LUMS both as students as well as professors later on. So maybe we have some perspectives to share that might be enriching for you all. Okay, so I do research on a bunch of topics, including digital development, cloud computing, and one of my recent research focuses on how do you counter fake news. What can we do about fake news from multiple dimensions and disciplines perspective? And I also work on machine learning, in particular privacy-preserving machine learning, and I'll unpack that later in the slides. This semester, I'm teaching data science. So those of you who might be excited about data science, you can come and take this course when you get to the junior level, or maybe a little earlier. So I'll request Dr. Ammar to introduce himself, and we will shuffle as we go along organically. Thank you.
Right, so I'm Ihsan, and my research is on optoelectronic devices, soft matter physics, liquid crystal devices, solar cells. So I'm basically, most of my work is experimental, but it's on the interface of engineering and physics. So that's basically what I do. This semester, I'm teaching Physics 100, Experimental Physics Lab. I think आपका orientation session, sorry, the enrollment session हुआ है अभी एक तो I'm taking two sections. There are 4 sections, so I'm teaching you 2 of those. And I'm also teaching statistical mechanics, which is basically thermodynamics. Okay. Yeah, so that's basically an introduction to ourselves. So Dr. Ihsan, I'll allow you to. Should I just go through? Okay, so basically the purpose of the session is to create awareness about academic pathways and share some of our perspective, but we really want to know what your questions are. About SSC, what it's about, Ihsan mein kya hona hai, so on and so forth. Okay? And basically, we wanted to be candid. So basically, yeah. So especially, we'll have lots of time at the end for questions. That's one of our priorities. Okay? We'll try to be quick with the PowerPoint. That came questions to ask again. So the focus is on the big picture of your journey. What does the 4-year journey involve, and what are some of the key milestones? What are some of the things you should watch out for? Common pitfalls, so on and so forth. Any questions basically that you might have and that we can help you with. Okay. Right. So just to introduce you a bit to SSC, I think you've had sessions with the Dean and the VC already, but we'll just recap a bit. SSC was established in 2008. So you are the 14th batch in that sense of SSC. So you have quite a lot of alumni now also. So it's basically one large family. What SSC was set up to do was not just कि अब LUMS है तो अब LUMS business करा रहा है तो अब LUMS science and engineering भी start करते हैं. That's really not the point. The point of SSC was that if you look at institutes like the Indian Institutes of Technology, IITs in India, yeah, you look at Sharif University in Iran, yeah, if you look at बहुत बड़ी बात है, but if you look at, for example, the academic rigor followed at Caltech या MIT, the question is, there is no short of human resource, no short of students with aptitude in Pakistan. Maybe the one bottleneck potentially could have just been how they're being taught and what they're being taught. Right, so SSC has basically been made to remedy that situation. So what we try to do, and we'll talk about this more, is that we try to realize SSC's mission through our core curriculum. Even if you're here to study CS, we make you sit in biology classes and chemistry classes, physics classes, and vice versa. If you're here to study biology, you have to do differential equations, you have to do linear algebra, probability, you have to do programming. You can't escape now anymore from all the core disciplines that are out there. And we'll try to argue why that's the case. Basically, that's SSC's mission. Okay? Our coursework tends to reward consistent hard work. What I mean with that is basically that a lot of courses would have most of the grades assigned on the basis of assignments, quizzes, general coursework, rather than KG 100% final exam hoga. So if you want to do well here, you have to be consistent. Take it throughout the semester. Another thing that SSC is sort of pioneering in Pakistan is that we try to involve both graduates as well as undergraduate students in research alongside faculty. So all faculty members at SSC have their own independent research groups. And every department tries to capture most of the core areas in that discipline. And what we allow and encourage students to do is to be a part of that research, because good universities, and some of the best universities, are those in which there is back and forth between what's the cutting edge and what's being taught in undergraduate classes. So we try to, that's part of SSC's mission, as I like to say. So why study science and engineering? Basically, the idea is that most 21st century challenges, open problems. Now, क्या open problems हैं? इस वक्त हमारी एक open problem है like Pakistan floods आए हैं, right? So climate change, flood management is a 21st century open problem. Similarly, the provision of drinking water for an ever-growing population, is also a problem. But I mean, okay, fine, there's enough water, there's enough clean water in the world, but the distribution is not fair, not equal, right? So how do we remedy that? Energy is an issue. I mean, this year, Europe doesn't have energy to, heat itself in the summers, in the winters. So, but Pakistan में हमें अच्छी तरह पता है energy क्यों issue है, कितना issue है, ठीक है, economy से लेके balance of payments के issues से लेके, load shedding, whatnot. Then things like COVID, now COVID आपने खुद देखा है कि, आप RT-PCR करा रहे हैं, real-time PCR. Real-time PCR is a technique which uses the polymerase chain reaction, combines it with optics. So it's all interdisciplinary. Education, में हम online चले गए थे, all of those things that happen. So education in the 21st century is also, education for everyone, accessible education, affordable education, that sort of things. There's cybersecurity. Dr. Ihsan can talk a lot about that. I think he will when he talks about his research. That these are great challenges. And then if you think more about technology, battery technology, you can make all the solar cells in the world, but if you don't have a means of storing the energy, then you still have no energy at night. Similarly, electric cars are limited by range. So we still do not have an answer to this. And this is still an open problem. So there's lots of open problems, but the thing is that almost all of the open problems are interdisciplinary and multidisciplinary. So you need to understand more than your core subject in order to be useful, in order to be able to contribute towards these problems. हाँ ठीक है, जब भी कोई टीम बनेगी तो उसमें हर बंदा अपनी expertise लाएगा, but you have to be able to understand each other's languages, which is what SSC was trying to we try to encourage. Can you maybe?
So I'll just add a couple of points to what Dr. Ammar very well sketched about SSC's core mission and how the curriculum is structured. So I'll just mention a couple of things before we talk about some specific research things. One is that one of the amazing things about learning and education is that no one has a monopoly on good ideas. So if you can think hard, work hard, you can do amazing things in life. So one of the greatest things, one of the great things that the top-notch research universities have done is that they bring in people who are excited, who want to learn and change the world. And then they create that ecosystem which is needed to make to aim for a better and a different world. So that's a high-level philosophical point that you all can do amazing things as long as you can imagine, aspire to change the world for the better. So that's one. The other thing is, like Dr. Ammar very rightly pointed out, the grand challenges we face today, they don't lie at disciplinary boundaries. So the grand challenges like climate change or fake news or energy, etc., these are not problems that you can say, oh, well, this is a computer science problem only, or this is just a biology problem. Most grand challenges we face actually cut across many disciplines. And you being conversant in many, in several basic sciences and engineering will enable you to actually approach those problems from a very different perspective. So I can share my own perspective. When I was an undergraduate at LUMS, I took courses in economics, in psychology, and at that time I thought, I'm just taking it for fun, but I'm not sure if it's going to be of use in my PhD in computer science. And it turned out that those ideas that I learned in economics, for instance, of resource allocation applied directly to the problem I was solving in computer science. It was congestion control at that time, resource allocation problem. So partly you have to trust us that the learnings we will have with respect to science and engineering at this level is going to help you later on in really diversifying, tackling problems which might not be accessible if you have just, let's say, computer science, just biology, or just engineering, and so on. And so with that perspective, because the reason I'm emphasizing this is that I've seen people, they come with the computer science, major perspective, and they say, oh, well, all other departments are other. And so as a result, they don't pay a lot of attention to those courses, and I think that's very limiting in my humble view. Okay, so with that, what we've done is we will share with you a couple of research projects, because we've also wanted this session to be a little more tangible for you, where multiple disciplines have brought perspectives that have really enriched the way we can solve them. So one of the research I'll be talking to you about is the problem of fake news. So we know that fake news has become increasingly prevalent, and it can have large impacts. For example, it can lead to polarization in society. It can lead to election interference and therefore impact democracy. It can lead to conflict, and there have been instances where fake news has had a devastating impact. One of the great challenges with fake news is its changing nature. So how many of you are familiar with deepfakes? Okay, so yeah, so with deepfakes, you can actually copy the voice and the picture of any individual with unprecedented accuracy, which means you've crossed the barrier of trust for many, right? So you can change the beliefs in manifest ways. So in order to tackle this challenge, you need not just computer science, just technology is important. You can detect things in automated fashion using advances in deep learning. So our group has been doing that, but that's not sufficient. Useful, but not sufficient. So in our team, we have development economists who are working on behavioral psychology. What are the cognitive factors that derive belief in misinformation? For example, misinformation is oftentimes emotionally evocative. You know, it's designed so that you can quickly click and share information and so on, right? Similarly, do we have the cognitive budget to actually skim through every piece of information in social media and determine whether it's valid or reliable or not? So there are many cognitive factors. So one of our research projects actually recently appeared at the Harvard Kennedy's Misinformation Review, where we talk about cognitive reflection and vulnerability with misinformation, for instance. Okay, so in our team, we have Dr. Ashali, who's an assistant professor of economics. She's one of the leaders in misinformation research in developing countries. And besides myself, we also have Dr. Ali Raza, who does fantastic work on machine learning, deep learning, systems, etc. And we have been working on a range of topics from user education to designing deep learning systems to detect fake news and so on. So you know, I could, if I were approaching this problem just from a computer science perspective, I wouldn't have seen you know, potential impact. So we were in conversation with the government during COVID to ensure that the insights that we came up with can lead to policy action, for instance, right? And so it's really essential to have the perspective of multiple disciplines and being conversant in it to solve problems, the grand challenges we face in our society.
Right. So I'll just share one more example. So this is a project that I was recently involved with, and this is something I never actually done before. It was a project on microplastic pollution. So basically, as I found out, microplastics are plastics with less than 5 millimeter in size. So plastic that has polymers, right? So how do microplastics come about? For example, you know, if you have a bottle of Coke or a Nestle bottle of water, whatnot, that ends up eventually, you know, in the water. You have UV rays from the sun come in, that breaks down the polymer, and eventually, due to wave action, the polymer becomes what are microplastics, the small bits of plastic. Then another major factor is fibers from clothing. Then you have these beads that are used in you know, in industry to make molds and to make plastics. And then, you know, you have micro beads in things like scrubs and so on and so forth. So all of this is basically ending up in our rivers and ending up in our oceans, right? And recently, there have been studies where people have shown that microplastic has been found in basically the blood in blood samples. So like, there's a high chance that we have plastic in our blood right now because it's, you know, small plastic particles you ingest and they can pass through the gut into your bloodstream. So this was a project, and the team basically that I got involved with was Dr. Safiullah Chaudhary, who's an associate professor in the Department of Life Sciences here. So led by Dr. Fawzia Parveen, who's an assistant professor at Khan University, and myself from the Department of Physics. And the research question was that, you know, if we study the interaction of local environmental bacteria samples with microplastics, you know, what's happening, what's basically happening out there. Why are we interested in it? Because bacterial degradation is one of the main pathways in which you can, you know, you can destroy these microplastic particles and have some sort of bioremediation. Because you can't send someone out there to sample and pick up each piece smaller than 5 millimeters, right? So it's a huge problem. It's actually one of the biggest anthropogenic, you know, polluting factors out there right now. So what we did was, actually not myself, but some other members, Dr. Fawzia mainly, they went to Mahmood Booty and they went to Hodyala Drain. Hodyala Drain starts in India and ends in near Lahore. And Mahmood Booty is one of the biggest landfills, one of the main landfills where all our waste goes. I think it's near the ring road, but I didn't really go so much. So I don't know how to do any of this, you know, how to take bacterial samples, how to culture them, how to identify, you know, bacterial types. I have some idea because I took Bio 100 what plasmids they think, you know, they try to figure out what it is. But so I had some idea, but not a lot. You know, and so in this interdisciplinary team, they did like long-term interactions of microplastics with local bacteria strains. And we identified, for example, that Bacillus, so we looked at Bacillus subtilis in one of the species of bacteria. What did we do? So they did the thing that biologists do and environmental scientists do. So I basically had a polarizing optical microscope. And so basically we were able to do some novel polarized optical microscopy of looking at the interaction of, so basically this is a control sample. This is a colony of bacteria. What they've done is they formed a biofilm after 60 days. And so we can see how the biofilm forms in biodegradable and non-biodegradable bacteria. And this is really cool. This is a scanning electron microscope image that we've taken at SSC of, so this is a bacteria, and it's actually eating this plastic sample here. So like really cool stuff. And we were able to find out, that better interaction was observed with biodegradable rather than non-biodegradable polystyrene. And we were also able to identify which local species found in the Hodiara, in the Mahmood booty interacted better, in breaking down the bacteria. So like very interesting stuff, but I could never done this. So you need interdisciplinary people to come together to do this. So Ihsan, I'll pass it on to you.
Thank you, Dr. Ammar. So I will just quickly again drive home the key point of presenting to you these two research projects, which is that when approaching different subjects, you should be both open and involved with respect to whether independent of which major you eventually end up choosing. Okay, so given that vision that we had, which was that it's really important to train students in both science and engineering, we structured the SSC curriculum to realize that grand vision that we had. So our curriculum is structured both from a breadth and an interdisciplinary perspective. And so at the beginning, you take courses in basic sciences and engineering. And then gradually you start taking more courses in your major as well as other elective courses. You will have the opportunity to work on research projects as part of the courses, for instance, or as part of working with professors in their research groups, or even doing internships, if you will, depending on, of course, different disciplines and so on. So the other important learning mechanism is the final year project, which we call the senior year project or SBASSE. It's a 1-year long project that you do at the end, in the fourth year or your senior year, where you will bring together all the learnings you have had to solve a large enough problem with the supervision of one or more faculty members. Right? And so that's an important thing to keep in mind, that you need to decide before the final year what SBASSE do you want to work on. So I won't go much into sort of the GPA stuff, but it's there just to re-echo the point that student evaluations are scaled on a 4.0 GPA scale, and so one of the things that Dr. Ammar highlighted that I would like to highlight again is that there is no substitute of consistent hard work. So LUMS is going to nudge you because every semester you will end up taking new set of 5 or 6 courses in general, and so it's going to nudge you with quizzes and assignments and so on. But I can share my own perspective that consistent hard work, making sure that before the next session or lecture, the previous lectures are well rehearsed. There's no substitute of that in terms of enhancing your learning. So keep this in mind. The grand goal is learning. If you are passionate about what you do, learn, these grades should follow. Okay, so they are means to an end and not the end in themselves. That's an important point to consider. So one of the key milestones you need to think about is your major. What major would you like to do? And if you're interested in doing a minor, what minor would suit? And that will involve a lot of conversations between yourselves, with your faculty and seniors, and do those conversations. As an undergrad, I was very curious about why people do certain, think of certain professions. So I would go to my seniors and professors and say, why are you doing what you're doing? What's the motivation? I would like to learn, maybe it connects with me, it gives me better perspective on how I might choose things to do, choose things and so on. And so have those conversations regularly. And as you learn and go, keep those conversations going, and your ideas will also evolve, and that's a good thing. Okay. Then the second thing I mentioned was about do work on a project, an independent project, either as part of a course or an independent project within a research group with a faculty, because that's going to really enhance your learning experience outside the structured learning that you get in a course, right? So typically in a course that you would take, all answers are known, at least to the faculty perhaps, and you have a very structured, but when you do research, many of the answers are unknown. That's why we're doing research. Even the questions need to be made precise before you can find those answers. So do try to work on a project or internship as part of a journey. And finally, like I mentioned, the courses you take is going to help you, hopefully, and the conversations you'll have to pick your senior year project. I've seen so many students working within, for example, computer science across boundaries, students taking senior project in computer science, and intersected with computer science and biology and so on. And so there's a world out there to explore. And I really hope that you will explore that with full energy and perspective. Dr. Mark?
Thank you. Hey, so just some other points which we were brainstorming about different things that we should talk about. Yeah, you should think about. And one of them was basically the transition towards university. This happened to us, and I think we see this happen every every year. Which is, I think all of you you've all done well in high school, and so you're used to doing well, right? But the thing is, you're now in a rather more select group of students than you were in your A levels or FSC classes, right? So that transition is basically something that affects a lot of students to start off with. The first thing is that you have to try hard from day one. You can't say abhi shuru hua hai 6 hafte baad dekhenge 4 hafte baad dekhenge. So you have to work hard from the first day. That's the first advice. The second thing is just because you're used to topping the classes you were in doesn't mean that will still happen. It doesn't mean if that doesn't happen, so you failed or something. It's just everyone has their own pace. So be ready for that transition and don't get disheartened. KG सब तो सब बर्बाद हो गया और अगर एक सेमेस्टर ठीक नहीं हुआ जीपीए ठीक नहीं हो सकता ऐसे नहीं होता हो जाता है ठीक है तो and the other thing is that balancing academics with non-academics. A lot of students before university think that societies are something that are sort of academic, because if you join lots of societies and do lots of things such as Lumen, space and all of that, then somehow that affects on your academic transcript, but it really doesn't. Societies are there for your for your social engagement and to keep you sane, so and so forth, right? But it's not work. This is you think about society more as academic play as just play, right? So balance that. Just because you do you join 10 different societies would not increase your probability of getting to a good grad school as a slightly higher GPA, as a slightly more involved research project would. But still contribute towards them because they add towards your personal growth. They help you make friends and they strengthen those bonds. And those bonds are very important in life. But balance them. Okay? Don't let one thing be overbearing on other things. Okay? So you have to be careful about that. And planning is key. Plan ahead for the semester. The first year matters a lot, but all years matter equally. ठीक है, ये बात भी GPA मैथमेटिकली निकलता है ना, just divide the credit points with the credit hours, so ये नहीं है कि first year खराब हो गया तो बस जाया हो गई है, ऐसे नहीं होता, ठीक हो जाता, ठीक है, अच्छा, and of course invest in your personal development so and so, ठीक है, तो I think we've talked about most of these things. Another thing that I just want to highlight is meeting faculty advisors. So I think the Office of Advising has probably told you that already, but yeah, we'll tell you that. But you're all assigned faculty advisors. Meet them. Don't skip the meetings. Faculty is also busy, so if you start skipping meetings, they also start forgetting, and then the system breaks down. Between the student faculty advising thing. So go to your meetings there to help you. Okay, and they have lots of perspectives to share. So make sure you attend your faculty advising meetings. Okay? So I'll say a bit about this and I'll pass on to Dr. Ihsan. Making good academic decisions, good versus bad reasons to choose a major. So failing well, so we'll share this presentation maybe and then they can have a look at this link. So everyone naturally has a negative, basically when we say that choose a major for the right reasons, इसके बारे में मैं बस ये कहना चाहता हूँ कि you guys are starting your degrees in 2022, ठीक है? You'll graduate in 2026. You'll be about 21, 22, between 20 and 25 years, right? You would be employed till 2070 at least. Like, so I think the mean retirement age for you guys will be 2070 to 2080, right? So now the thing is that आजकल CS का बहुत स्कोप है, right? I mean, but the thing is कि 2080 में किस चीज का स्कोप है हमें नहीं पता, किसी को भी नहीं पता, right? But that's how long you're in the workforce for, ठीक है? That's how long you're working till. So make good decisions. Follow your heart. Yeah, follow your interests when choosing a major. Not just के आजकल सब एक ही चीज कर रहे तो हम भी वही कर लेते हैं, right? आपके पास अपॉर्चुनिटी है बहुत अच्छी, उसको इस्तेमाल करें और अच्छी रीजन से अपना पाथ चूज करें. ये पाथ ही फाइनल नहीं होते. I mean, you can always transition to other disciplines later on in life, but it does set you on a path. So choose it well. Pass it on to Dr. Ihsan, then you can continue.
Thank you, Dr. Ammar. I think one of the really important things to keep in mind is that failures will happen. At SSC, there will be instances for most of you, if not all, where you would not get the grade that you aspired for instance. And really the key thing would be how you view those experiences and failures in code if you think of them as failures. When I joined LUMS as an undergrad, the first, at that time we had a quarter system, which was much smaller, shorter than the semester system. My first quarter was the worst that I had in my academic career. Everything flew very fast. I've done my A-levels and I have ample time, but here you have like 5-6 courses, flew like this. And so, I reflected upon them and said, how could I adjust better, do better, and so on. And that was an iterative process of learning. So, like Dr. Ammar said, don't take it too hard. View failures as an opportunity to learn more because it's a feedback signal. And all of you are analytical. You can reflect on why things did not happen the way you had envisioned, and then work backwards. This is really important because I've personally seen many students, and I understand it's natural as well, taking great setbacks too hard, and then a lot of same things go south if you repeatedly do that. So if the focus is on learning, I can tell you, you will end up at a place that you will be happy and content. So focus on learning. Take failures as opportunities for growth and learning and reflection, and come out as a better person. So the other thing is that seek out support. I've talk to so many students, they view support as an act of weakness. But I really believe that seeking advice and support is an act of independence, because you are reaching out and saying, you know, can you help me with this? Or I'm thinking along these lines, what is your perspective? Or I'm struggling with X and Y. How do I navigate this? So please seek out support, and that support might be to your colleague, your peers, to your seniors, teaching assistants, or faculty. Like Dr. Ma said, you should really plan to meet advisors, or randomly pop up at faculty offices and say, hey, do you have 5 minutes? I have this question in my mind I would like to discuss with you. And I think most faculty, if they have time, should be able to make time, right? So do make use of all those possible interactions you can have and support that you can seek, so that you can really maximize the benefit you can derive from the experience at SSC. Okay, so just continuing with the previous point that struggling, it's not uncommon to struggle. By struggling, I mean not being able to do as well as you might have imagined or thought. So, the first year in particular sets a very important precedence for you. So I would, based on my personal experience, I would highly advise you to, get going from the first semester in terms of understanding how LUMS works, how courses work, and try to sort of get into the transition, get over the transition of tertiary education, which is undergrad education in this case. And like I mentioned, seek support. Don't worry too much if you don't get a hand of things. Things will get better. Remember that it's an iterative process. Things will get better for a really long time, and so keep trying. Okay, so perhaps Dr. Ammar, you can cover the first 2 years. Then
right. So and you've done enrollment already, so you have some idea about this. But basically, in the first year you have it's a common core. The most important thing here for all of you is to please complete the common core year in the first year. Don't leave labs and some courses you're not interested right now for subsequent years. The reason for that is the first year courses, first they're designed to be taken now so that you take this content, a lot of the skills we teach you, the programming skills, the mathematical skills, the physical skills, into your major courses. So the second thing is it's a scheduling issue. I have so many students come up to me every year, we need to graduate. We did not take the physics lab in the first year, and please do something about it. And my schedule does not match with any of the available labs because I'm a senior year student and my courses are designed for my batchmates, not freshmen. So do the first year in the first year. Do not leave these things for subsequent years. You have 2 courses in physics, mechanics and modern physics. We'll start with mechanics in fall. Then you have introduction to programming, that's also in fall, and I think it's also offered in spring, but most students take it in fall. You have introduction to chemistry, introduction to biology. This one is, I believe, taught in spring. You do calculus 1 in this semester, then linear algebra with differential equations in the following semester. Writing and communication, most students do this semester, but I think some might also, I think it's offered every semester, so you sort of have a choice there. And Islamic studies. I think that basically covers most of what the SSC core curriculum teaches in the first year. And so just do these courses in the first year. Now the second year is when you start your majors. Okay. Now you're mostly a major course, some electives. I would like to point out, Dr. Sabi might have already mentioned this yesterday, there are some scholarships available in the basic sciences, biology, chemistry, math, and physics. These are offered to, I believe, so depending on GPA, I think so. The top 2 students in each discipline get their fee waived. So I'm not sure of the specifics, but there are scholarships in the basic sciences, merit-based scholarships based on your GPA performance in these majors. So do check out that also. You get different faculty advisors assigned in the second year because पहले साल common होते हैं, second year में आपकी major faculty ही आपको assign होती है, ठीक है? And you can also start planning your minor at this stage and try to take 1 or 2 courses from your intended minor at this stage also. Okay? And let Ihsan talk to you about your 3rd and 4th years.
So once you end the second year, third year you will be taking, especially in the fall, very important 4 courses of your major. And that's a very good time to start thinking about what you plan to do once you graduate. So for example, if you're interested in graduate school, master's or PhD, then in the spring of the 3rd year, it's a good idea to start looking out for research internship positions, either within SSC or maybe internship positions outside. So it's very common, for example, in SSC for students to work with faculty members in their research projects. So at the moment, for instance, I'm supervising, I think, more than 10 undergraduate students working on fake news, machine learning, etc., etc. And so, so spring of 3rd year is a great time. Summer is also a good time because at the end of the fall, you will be applying for graduate school, right, in the 4th year. So that's a very important time to gain that research experience or independent project experience so that you can really have a strong profile for graduate school. And if you want to go to industry, then taking more advanced courses by spring and in the senior year would really help you be competitive. And if you want to do entrepreneurship, of course, all these things are still extremely useful in order to set your background. So that's pretty much 3rd year. And in the 4th year, and the way the SAP is structured is that you will have time to take more electives, and also one of your major focuses will be on your senior project. I would perhaps advise more than 50 senior year projects, and what I've seen is that students do amazing things, provided they plan ahead. So summer, end of 3rd year is a great time to start thinking about what project excites you or may excite you, having those conversations and finalize the 1 or more supervisors, and then start your senior year project then, and it can really lead to amazing things. So 1 year is a big time, so 2 semesters. So your final year will be very much focused on the senior year project. And also applying for graduate school if that's your interest, or looking out for positions in the industry, or thinking about entrepreneurship. So that's that. And Mark, you want to talk about students who might be interested in taking 1 year doing research? I think you had a plan. So if someone wants to spend maybe a year.
Right.
Is that something?
Yeah, basically, I think that's the point about graduate school, is that a lot of students wish to transition towards graduate school right after the end of the 4th year. It was 3 years khatam, and then we go to our grad school. To do that, what you need to do is that you need to apply in the fall semester of your 4th year, because most US applications are due in December. So basically, you have to apply in the beginning of the 4th year. तो उसमें बस ये कि आपका 3rd year वाला GPA आपके पास होता है, जो आपका 4th year का पहला semester complete नहीं हुआ होता है. If you don't do that, then you can always take 1 year between going to grad school and after your graduation. In that 1 year, you could go to industry, or you could just do research. You could continue your SPROJ, as an independent research assistant. Or you could teach for a year, and so forth. So I just want to highlight that there are multiple ways that people go to grad school. Some go directly afterwards, some take a year and then go. There are advantages and disadvantages to both, and you can plan your studies differently, depending on what path you choose to take. Right. So I think what we'll do now is that we want to hear your questions. We have about 10 minutes for questions. So yeah, I want to answer any questions you might have. Okay?
Are there any merit-based scholarships in the first year?
Are there any merit-based scholarships in the first year? So I'll answer that question.
Rebecca would know, I think.
Actually,
मैरिज स्कॉलरशिप से भी तो अगर आपको मैरिज स्कॉलरशिप मिला है if you are awarding मैरिज स्कॉलरशिप so you would buy
in first, basically, if you do really well in the first year, I believe when you go into the second year, there are merit scholarships. So the batch topper
And if I may suggest, if your questions can be more directed towards academic journeys and tips, that would be really beneficial because I think Rebecca and Noman are experts in scholarships and other aspects. Yeah.
You talked about talking to different people about their motivation.
So I was inspired by some experiences I had as an undergrad. One, so when I first did a teaching assistantship for a course in networking, I loved it. And I felt that, I loved the experience of helping others see the beauty in mathematics or computer science, and I just loved that experience. So that was one motivation. The other thing was that I took advanced courses and did research projects, couple of research, and I just loved the adventure of working on a new problem which even the faculty doesn't know how to solve, and then making small inroads in them. And I just felt that that this is something that I enjoy so much that I'd like to do for the rest of my life. And then of course there are other motivations of being a professor, and I'm happy to share that at some time. Yeah.
How is your idea that
This is very interesting, fascinating thought. What I can share with you, and Dr. Ammar, being your physicist, will also share with you his perspective from a computer science perspective. A lot of work is being done on quantum computing, and that really borrows a lot from quantum physics. So there are lots of large-scale computational research problems that are being solved that require both lenses, the computer science lens, the big data and machine learning lens, as well as the physics lens. So I think that's interesting. As long as you feel excited about working in that space, and I would encourage you to take more courses in these directions and then see whether you like those courses and you feel that it's your calling. And if you end up thinking that, this is very interesting, I'd like to continue with it, absolutely. Anything about physics?
Yeah, so you basically asked if you want to do a double major in CS and physics. So SSC does have a policy for double majors, it's in your handbook. Right now, the policy typically, you have to take quite a lot more credit hours than you would need to take if you were to do one major. And so that can take more than 4 years, it can take up to 5 years, but it is possible to do a double major. What is more easier to do and more feasible in 4 years, and a lot of people do, is do a minor. So you either major in CS, do a minor in physics, or major in physics, do a minor in CS. That's a more feasible option in 4 years. Or you can do a double major, but then that's more courses, that's 5 years. It's really a 5 years, like a feasible 5 years नहीं होता है जितने credit hours हम लेंगे. हाँ जी.
Go about starting your project.
Right. So the question is, in our final year, how do we go about finding out क्या cross करना है? Basically, what you do is you speak to faculty. So by the end of the 3rd year, you have typically been taught by most professors in your department. So you know what they're doing. You can approach them and ask them, do you have an idea? Is there a project I can be involved in? That's how most students get involved. But you can go to other departments in SSC also. You don't have to do an project in your own department. So it's the आवाज नहीं आ रही, थोड़ा ऐसा बोलने के बाद
And you have to
So in expert depends. Some experts are independent projects, some are group-based projects. It depends on a case-to-case basis. But it's original work.
Thank you.
ठीक है. हाँ जी.
In SSC, most critical activity.
Guys, I start.
Most critical activity is for the third or can we utilize semester later on in critical activity?
बिल्कुल हाँ, like you can use the summer semesters for pre-electives or university distributions. Absolutely. Yes. Right. So a minor is basically so if you go to your handbook, every department has every discipline has set out the conditions, which if you meet those conditions, your transcript will say that you have also completed the requirements for a minor in that subject. So, for example, in physics, we typically require, I believe, 17 to, I forget the number, 17 or 19 credit hours of physics courses. And these include some of the core courses, but then you have to take some courses in addition to that. Similarly, in CS, you can highlight the.
Yeah, so like Dr. Ammar said, the idea is that you take foundational courses, less in number in each of the disciplines. And so every department has a criteria, and these courses, if you take, there are some options as well, then you have done sufficiently, you've done sufficient enough to be able to qualify as a minor. So it's a recognition also that you're well versed in at least the foundations of another discipline aside from me. You haven't taken biology? Yeah. So everyone, but the good thing is that the assumption would be in the course of time, we may go prior. For example, I studied computer science, but I have no background in computer science at A-levels. So in these foundational courses, and you'll be able to something that anyone without a prior background should be able to do that. But there will always be some, but in my experience, people after a few weeks can do reasonably. It's going to be challenging, but very doable, and you can do it really well. I have lots of examples of students who got not do biology, but they're amazing here in biology.
How many courses and so the question, how many courses are added per semester if you do a minor?
So I think for a minor, there are like 5 or 6 courses. I don't exactly remember. 5 or 6 courses you need to take. No. So for example, I'll just give you an example. If you want to do a minor in computer science, you will need to take an introduction to programming course, a data structures course, a pre-plan course, perhaps an algorithms or an operating systems course. And you can take these 5 courses in your 5 years, and then you will have
4 years.
4 years. So the question is that if your project is very broad, senior project, is there a requirement that you have to have X% of CS, so to say, in your senior project? The thing is that at the first level, when you're doing a senior project, you need to sign on an advisor, or maybe 2 advisors. And so they are going to essentially, along with you, determine whether it fits in that particular discipline or multiple disciplines. And generally, it's an organic process, and they determine everything.
Thank you.
So if you want to, as I understand, if you want to do a senior project, let's say in bioinformatics or computational biology, then you will need to take some courses, not a requirement, but just to build your background in computational biology, as well as, for example, relevant computer science courses like algorithms, so that you can really do a senior project that's worth your while. Yeah.
So the question is, if someone is the major in physics, chemistry, and biology. So what job did you do after
Okay.
graduation? And math. It's a very good question. So basically, answer is it depends. It depends. For example, so unlike a lot of other more developed countries out there, there's not lots of companies here that directly hire physicists to do physics. But there are companies, for example, consultancy firms, data analytical firms, that can use the skill that a physicist has in their companies. A lot of our people go to those kind of consultancy-based or data-driven business companies. Similarly, so I know for a fact Packages is a company, Enclose a company that has hired chemists from our department directly. For biologists, I believe you can find a job in pharmaceuticals, so on and so forth. There are also government organizations which hire physicists and chemists and biologists. For mathematics, once again, consultancy is an option. There are companies like Affinity, I believe, that was directly hiring our graduates, so on and so forth. So there's lots of companies out there. But I guess I hope that answers the question. But we will have more discussions on the major day. So there'll be a separate day to discuss it. Guys, can you keep speaking for like 2 minutes, and then we conclude the session. Better than
2 minutes. And just to add to what Dr. Mar said, I think it's important to, when you're doing a major, think about the skills that you're learning. So this time, I'm teaching data science, and I have a teaching assistant who's a physics major. He did really well in my course. He also took a bunch of other computer science courses, and he has an excellent taste of mathematics, statistics, machine learning that he has, in part of which he has developed as a physicist. He said, I'm interested. I said, wonderful. You are aware of many of the problems that physicists are working on, especially large-scale computations. So really, in your life, if you do a major X, very important things will be the skills that you have learned, the learnings you have had, because you are going to diversify. And then, I think if you look at the future work, people will have multiple professions in their lives. And really the key learnings that you will acquire will be these central bits. So take courses, explore, and then see how things pan out. One last question, and we are going to end that. Yeah.
I will take calculus or pre-calculus. If no calculus by ourselves.
Computer science के लिए आपने major लेना है तो I think there are 3 courses that you need to take. One, I think introduction to programming and calculus, and then you get the minimum GPA requirement. The average GPA I think is 2.7. If you get that, then anyone can get into it. Okay, I think I promise this was the last question. I'll take a question offline. Thank you.